let's understand reciprocal trigonometric functions, which is secant, cosecant, and cotangent in the unit circle. So let's understand these points first. So just like the previous videos, I have b prime that I can move it around. As I move b prime, the point B travel around the unit circle. And this S is the point that is the intersection point of perpendicular line going through B, goes like this, okay? And then this T is the intersection point of the perpendicular line going through A, which is 1, 0, and OB. So line OB goes through there, and just like the previous videos. And P is 0, 1, and Q is the intersection point of horizontal line segment going through P and line OB. So if you extend OB and if you extend P, it's going to intersect at point Q. So notice that segment QP is 1.56 unit at this point when the radian is 0.571 radian, and OT is 1.19 units, OQ is 1.85 units. And let's understand what the secant is and see these reciprocal trig functions. So secant, let's calculate secant of x, which is the radian. So radian is 0.62, so I'm going to choose this one first, and then I'm going to plug this 0.624 for x. Oops. I choose this, gives me 1.23. Cosecant gives me 1.71. Cotangent gives me 1.39. And you notice that secant, which is 1.23, is exactly the same as the measurement or length of segment OT. Cosecant is the same as the length of OQ. Cotangent is the same as the length of this segment OP. So OT from here to here is equal to cosecant. No, I'm sorry, secant. And OQ is the same as cosecant, and OP right here is the same as cotangent. So let's move this B prime so that the B moves around the circle to see if that actually stays the same. If I move B around, still those relationships are invariant, meaning that the relationships are not changing. See that? So now secant is still the length of OT, cosecant is still the length of OQ, and a cotangent, no matter where I move, is still the same as length QP.